An airplane can fly 900 miles in 3 hours when it's traveling with the wind. However, the return trip against the wind takes 5 hours. Find the speed of the plane in still air and the speed of the wind. If you've ever flown a long distance in a plane, you may have noticed that the flight time is different for the outbound flight versus the return flight, and that is generally due to the wind. When the plane is flying with the wind is pushing the plane even faster. It's helping the plane, so the plane can go faster when it's going with the wind. But when it's going against the wind is pushing against it and slowing it down. So when it's going against the wind, its speed is going to be slower. Now in this problem, they're asking us to find the speed of the plane in still air and the speed of the wind. So those two quantities are going to be what we put in our let statements. First, we will let the speed of the plane in still air be x. When we say in still air, what we really mean is the speed that the plane goes with its engine, without the wind helping or hurting. It's just how fast the plane can go without any sort of a wind. Then the other thing they're asking us for is the speed of the wind, so that'll be our next one. Let the speed of the wind be y. Now, just like the other problems, we're going to organize our information in a table. So let's make our table. It's going to have 2 rows and then 3 columns. We're going to label the tops of the columns rate or speed times time equals distance. Because in this problem, we're dealing with speeds, that's what they're asking us for, and times and distances. And this is the relationship between those quantities. Speed times time equals distance. Now, when we label the rows, we have to be careful. Some students want to label the rows plane in still air and wind. But the information that we're given doesn't relate to anything that's happening in still air. The first leg of the flight, where the time is 3 hours, is when we're traveling with the wind, and then the return trip is against the wind. So we have to label our rows with the wind and against the wind, because that's the data that we're given. So I'm going to write with wind and against wind. And then let's fill in our table. For the rate, another thing, students always want to start by saying x and then y, but these problems are a little bit different. The plane's speed when it's going with the wind isn't x. X was the speed of the plane in still air. When the plane's going with the wind, it's actually going to go faster because the wind is pushing it forward. Now the speed of the wind we said was y, and since that's pushing the plane forward, it's adding to the speed. And so the speed of the plane with the wind is going to be x plus y. That x miles per hour comes from the plane's engine, and the y miles per hour is the additional speed it's getting from the wind. But what happens when it goes against the wind? It actually ends up going more slowly, and it's the same amount more slowly. It's y. So the engine pushes that plane x miles an hour, but because it's going against the wind, its speed is decreasing by y miles per hour because the wind is pushing against it. So when it's going with the wind, the rate is x plus y, and when it's going against the wind, the rate is x minus y. These motion problems are a little bit more difficult than the interest and the mixture problems. There's different varieties, and we have to put a little more thought into the quantities that we're putting into our tables. Now let's continue. Let's look at the time. We're told that the time the plane travels with the wind is 3 hours, and against the wind is 5 hours, so we can fill those in. And just like before, we multiply the quantities in the first two columns to get the quantity in the third, because rate times time equals distance. If we take x plus y times 3, gives us 3x plus 3y. We distribute that 3. And then we distribute the 5 in the next one. That gives us 5x minus 5y. Now we have all of our information filled out, and we have two variables, so we need a system of two equations that models the situation. If we look to see what information we haven't used yet, we haven't used the distance, 900 miles. So we have to figure out how we're going to use that, where that goes. Is that the total distance when we add the two trips together? Is that 1? And the answer is that 900 miles represents both of the distances, because it goes 900 miles when it's going with the wind, and the return trip means it's also going 900 miles when it goes against the wind. So both of these distances here, 3x plus 3y and 5x minus 5y, both of those are equal to 900, and that's our system of equations. 3x plus 3y equals 900, and 5x minus 5y also equals 900. At this point, we need to solve our system of equations. We can choose between substitution and elimination, and either one works. It might look a little bit more like elimination will be better because the x's and the y's are all on the left and the constant terms are on the right. But there's something we can do to simplify this before we use substitution or elimination. I want you to look at the first equation, 3x plus 3y equals 900. In that equation, all of the terms are divisible by 3, so we are allowed to divide both sides by 3, and because everything's divisible by 3, it's going to make the numbers smaller and easier to deal with. If we divide the left-hand side by 3, that leaves us x plus y. On the right, 900 divided by 3 is 300. And we can do the same thing with the other equation. All three of those terms are divisible by 5. So with this one, we can divide both sides by 5. When we do that, we're left with x minus y on the left, and 900 divided by 5 is 180. So we have a new system of equations, but in this case, x and y don't have any coefficients aside from the invisible 1 or negative 1. So we're less likely to end up with fractions, and we don't have to do any multiplying if we want to do the elimination method. It's just nicer. So take a look out, because in a lot of these problems, all of the terms in an equation are divisible by the same number,